Force and motion are all around us. When you kick a ball, you apply a force and it moves. Push a door, it swings open. Force is a push or pull, and motion is the change in position over time. Think about a bicycle. Pedaling applies force, making it move. Stop pedaling and friction slows it down. Isaac Newton studied these concepts and formulated 3 laws. These laws, known as Newton's laws of motion, explain why objects move the way they do. We will explore these laws with everyday examples. Let's get started on this exciting journey through force and motion. Newton's first law of motion, or the law of inertia, states that an object will stay at rest or move at a constant speed in a straight line unless acted upon by a force. If something is not moving, it won't start by itself. If it is moving, it won't stop or change direction without a force. Imagine a car that won't move unless you press the gas pedal. A book on a table stays put unless you pick it up. Slide the book and it moves until friction stops it. Inertia explains why you feel a jolt when a car stops suddenly. Forces are necessary to change the motion of objects. Without a force, objects continue doing what they are already doing. Newton's second law of motion explains how force and mass affect acceleration, often written as F equals sin ma. The force applied to an object equals its mass times its acceleration. Push a shopping cart harder and it moves faster. An empty cart accelerates quickly, a full cart slowly. Throw a baseball gently and it doesn't go far. Throw it with force and it travels a long distance. This law shows why it's harder to push a heavy object than a light one. The heavier the object, the more force needed to move it. Newton's second law helps us understand how forces affect motion. Newton's third law of motion states, for every action there is an equal and opposite reaction. Apply a force on an object, and it applies an equal force back in the opposite direction. Jump off a boat, and the boat moves backward as you move forward. Walking involves your feet pushing backward against the ground, and the ground pushing you forward. Rocket launches are a dramatic example. Engines push gases downward, and gases push the rocket upward. This reaction force lifts the rocket into the sky. Understanding this law shows how forces work in pairs. Every action has a reaction, and these forces are always equal and opposite. This principle is essential in many technologies and natural phenomena. It helps us see the balance of forces in action. Newton's laws are principles we see in action every day. Seat belts in cars are designed based on Newton's first law. In an accident, seat belts apply a force to stop passengers and keep them safe. Sports demonstrate these laws. A soccer player's kick changes the ball's motion, illustrating the second law. 2 ice skaters pushing off from each other show the third law. In space, satellites orbit Earth due to inertia and gravitational pull. Engineers use these laws to design buildings, bridges, and vehicles. Understanding forces and motion allows us to create safer, more efficient structures and machines. Newton's laws are fundamental to engineering, physics, and many other sciences. They help us understand and shape the world around us. In summary, force and motion are essential concepts in physics. We explored how force is a push or pull that changes an object's motion. Newton's first law explains that objects stay at rest or in motion unless acted upon by a force. Newton's second law shows the relationship between force, mass, and acceleration. Newton's third law states that every action has an equal and opposite reaction. Real-world examples like pushing a cart, riding a bike, and jumping off a boat illustrate these laws. These principles have practical applications in technology, engineering, and sports. By learning these laws, we gain a better understanding of how the world works. Remember, these principles are the foundation of motion and force, shaping everything we do.